Can you start by telling me what birdcast is? I know what a forecast is. What is birdcast?
Sure. So birdcast or a birdcast is all about really predicting where bird migration is going to occur. And we are doing that presently by modeling using weather surveillance radar data that, of course, detects all sorts of stuff in the atmosphere besides meteorology, also all the biology that happens, relating that, the biological bird-dominated data, to various weather factors, and then building models from that. So that's kind of one of the core features of birdcast, which generally is a project which is a collaboration between ornithologists and computer scientists.
Okay, so why is it important to study migration patterns of birds?
So I think migration is interesting for a few reasons. There is a general public nature connection that is just, completely amazing when it comes to migration. It's one of those things that as soon as people understand that it's happening and that the magnitude of it is literally billions of birds migrating every year, there's an immediate connection there. So it's a way to help engage people with the world around them, something they just don't know. And this amazing, enormously huge spectacle. I think it's also really important to study it because birds are really great environmental indicators. The whole canary in the coal mine euphemism is real. I mean, birds are very sensitive to environmental change. So monitoring them helps us understand the health of our environment a little bit better, and bird migration specifically, because it is so closely tied over evolutionary history to changing climate and the way that the planet, sort of the pulse of the planet, has changed over time. It's a really good way of understanding, how birds are responding to the kinds of changes that we're seeing today that are obviously way faster because of the human-induced climate change than anything they've really experienced in the past.
So what are you seeing? Are you seeing them in places farther north than they were before?
Yeah, so interesting things are happening. So from the migration perspective, we certainly see that some birds are really tracking these changes. So, for example, anomalously warm late winters or springs in the eastern United States. Birds are migrating earlier with those warmer conditions, sort of the greening of the vegetation happening, tracking temperature and so on. There are some species of birds, mostly the short distance migrants, the one that spend most of their time in the United States, they're tracking those changes. Other birds are really experiencing a very kind of different modality where those that migrate on a calendar basis are coming into habitats sometimes where the habitat is advanced like 2 or 3 weeks and the birds are still on some other schedule. So we're seeing these kinds of both the tracking of changes in climate and local and extreme weather, but also these kinds of mismatches developing where birds are arriving too early or too late or at a different time than the resources that they're trying to take advantage of. So lots and lots of changes like that. And then just from the distribution perspective, just sort of where birds occur on the planet, there are lots of these situations where species are expanding farther north with increasing winter temperatures. They're able to stay around longer. They are able to get better territories because they've stayed around rather than migrating. And then they produce more offspring. So it's just this sort of feedback. And we see that happening too.
Okay, so let's talk about the technical aspect of tracking them using radar. Can you tell me how you do this? We know how to track rain and hail and thunderstorms on radar. How do you track birds on radar?
Yeah, so thankfully, there's a pretty long history of this. I mean, birds are really just like big raindrops, right? So it's sort of like a hydrometeor, but just in some other kind of package. So the notion of being able to think about various different products that the radar produces as a way of filtering, whether it's that it's happening in clear air and the pattern is very uniform and unique and it has a certain correlation coefficient and various different kinds of metrics that you can extract from the weather radar, we can use that as sort of a filter. As a human, when I look at it, just as a meteorologist says, oh, okay, that's precipitation. And this stuff that's a lot more uniform, that's much more regular and is actually not associated with anything when we ground truth it, that's meteorology. Oh, okay, we know that's birds. So there's some components of both. There's both the ground truthing historical perspective, and there's also the understanding of what the sort of metrics are embodied in the weather radar data, in the products and those moments that come out of it that allow us to do that sort of breakdown. So, and when we do that, as soon as we start to teach models how to recognize what we as birdcasters and you as meteorologists can detect on weather radar just by eye, then we can start to use machine learning and computer vision to start to recognize those patterns more quickly, relate them back to the metrics, and just sort of build from there, that we have more and more confidence that, oh, okay, this is biology, this is meteorology, and when we're talking about the biology, it's dominated by birds just because of the nature of the radar. A 10 centimeter, WSR88D is going to be a lot more sensitive to most bird targets than to, say, insects or some bats.
Yeah, I was going to say, there's other things you can pick up on radar. So how do you distinguish between bats and birds, or insects and birds, or other stuff floating around?
It's a real challenge, and it's definitely not perfect. We know that some of the times when birds are aloft, there's no question that insects are also in those pulse volumes. So we tend to look at it in terms of a couple of different ways. One, we know the seasonal pattern of bird migration from all sorts of other ancillary data, citizen scientists going out and observing when they're seeing birds on the ground, the increases and decreases in those numbers, the changes, etc. So understanding the phenology of migration to some extent and being able to map onto the radar data, oh, these pulses that we're seeing of biological activity, those correspond really closely in time to when we see birds moving. And oh, okay, these ones that are in the summer during the two peaks of when migration of birds occurs, we know that there's a lot of insect activity happening there. And oh, these places where there are, 10 million bats coming out of a cave in East Texas, like, okay, we can understand what that annular pattern is on radar. So there's some of it that's a little bit of trial and error that we're starting to learn as we go. Some of it is based on supporting information that we can use kind of to screen and to filter. And then some of it is also based on ground truthing with more sensitive instruments, finer scale radars and or thermal imagers, or places where we might go out and observe bats and insects and birds and say, oh, okay, here's what's represented in this particular pulse volume, and then relate that back to the weather surveillance radar data.
I can imagine in any scientist's career that there's progression, but this feels like a lot of progression. I'm curious, in your career, have you gone from like guy with binoculars to guy with all these tools who can suddenly really track birds? Has it been like a huge progression for you?
Yeah, it's been a pretty amazing transition to think about. The first version of Birdcast happened in the late 90s with the dial-up internet and, like our AOL accounts and whatever, where you'd actually have to have, we'd be posting the images that we'd actually be grabbing, we'd be paying for, and we'd be downloading them with a, satellite link in a room that you'd have to monitor if it was raining because the satellite would go down, and all this stuff. It was like, in order to get a forecast out and an analysis, it was heavily human in the loop. In fact, it was basically like the human was the loop, and it was very time consuming. And furthermore, to produce these kinds of continental maps to show the direction and the intensity of migration for like a single week would take months. So fast forward, 20 years, and now we're producing those things on the fly, and we can do it. We can drill down into the data and look at them from a county and state level. We can look at the continental scale. I mean, it's amazing how much has changed. And of course, also in that time, the whole notion of going out and, being with binoculars to monitor migration at a particular spot, and then realizing, wow, the power of relating that kind of observation, which is still super valuable. We have not replaced it. We're not ever going to, and I would never advocate for replacing it. But now we just have this really rich, larger scale with the remote sensing that we can relate the observations to and just kind of, grow our knowledge and excitement about it. But it's changed incredibly over the last, 20 to 30 years, almost unrecognizably so.
There's so many parallels between this and weather. You could literally be talking about weather and nobody would know the difference. When you're talking about, having to have your eyes on the sky while also using these remote sensing tools. It's really cool. It's very interesting.
Totally. And the wonderful thing was, back in the, in the 80s and 90s, when birders wanted to go and understand where good migration was going to occur, of course, they know, well, we know when in the spring, when there's a cold front approaching and the southerly warm air, is moving in front of low pressure, etc. Like, oh, good to go see birds. So let's watch the Weather Channel and figure out where that's going to happen. So in migration hotspots, it was regular that birders would be just tuned in cafes to like asking them, like, turn on the Weather Channel, like on the Texas coast, because we want to know when the frontal boundary is approaching so that we can figure out when to go see birds. And now again, 20 or 30 years later, like, oh, we have a dedicated site where the same radar data are actually telling us about the birds coming in rather than just, sort of the other information about where the precipitation is, where the boundary between air masses is, and what the birds are going to do. It's just a much more direct approach. But you can switch one for the other. Absolutely.
I mean, I had to take a remote sensing class in college. Is that something you see changing in the future here for like education wise, like remote sensing becoming a requirement?
Yeah, I think so. And the interesting thing from the birdcast perspective, radar is one component of what we do. I mentioned also the citizen science part and the people going out and observing. There are other remote sensing tools like acoustic monitoring and video monitoring and various other things that are going to integrate with these data. And that remote sensing part, versus the direct visual study or the direct human sensing, like, it's going to be really important to understand both of those, and in particular, the ways that they come together and interact.
Is there anything else you want to add?
Oh, just to thank you for the interest, and obviously there's a close tie between weather and birds, so it's really wonderful to be able to talk to a community that already understands like where we're coming from and why we're excited about these things. It's like, oh yeah, here's a connection that is super logical. So I thank you for that.
Yes, absolutely. Anybody can go to Birdcast and check it out and look at the maps you guys have, right?
That's right.
Hey, thank you so much for watching. While you're here, check out some other videos you just may like.